Let's learn about the basic operation of AC-DC converters and their characteristics by type. Why is AC to DC conversion necessary? The electricity supplied to homes and factories is a high AC voltage of 100 to 220 volts. While most of the electrical appliances we use operate on low DC voltages such as 12 volts, 5 volts, or 3.3 volts. In other words, if the AC voltage supplied to homes is not converted to DC voltage, electrical appliances cannot be used. Portable devices such as laptops, mobile phones, and tablets require a separate DC adapter, which acts as an AC-DC converter. An AC-DC converter is a device that converts high-voltage AC from an AC outlet into low-voltage DC. Home appliances such as TVs, washing machines, and air conditioners appear to only use AC because the AC input cable is directly connected to the product. But the AC-DC converter configured in a separate power circuit inside the product converts the input AC into DC and supplies DC voltage to various circuits inside the product. AC-DC conversion circuits that convert alternating current to direct current are of two types: transformer type and switching type. The transformer type generates the required output DC voltage with a simple configuration of a transformer for AC input step-down, a bridge diode, and a smoothing capacitor. This transformer type is a traditional AC-DC conversion circuit that was widely used before the switching type was introduced. The switching type consists of a bridge diode, a smoothing capacitor, a switching transformer, and a switching element on the primary side, and a diode and a smoothing capacitor on the secondary side, and a feedback and control section for constant voltage output. This power structure is called a switching mode power supply, or SMPS, and almost all AC-DC conversion power circuits use this type. The DC adapters and cell phone chargers around us are all switching type power supplies. Let's look at the circuit operation of the transformer type. The transformer type reduces the AC input voltage to an appropriate AC voltage using a transformer. The reduction in voltage in the transformer is set according to the turns ratio of the transformer as an AC-AC conversion. Next, the AC voltage, which has been reduced through the transformer, is converted into a pulse current by full wave rectification in the bridge diodes. Here, the pulse current is a waveform that is an intermediate form between AC and DC, and is similar to the Hart pulse waveform, hence the name pulse current. And finally, it is smoothed through a capacitor, so that it outputs a DC voltage with little ripple. Smoothing with a capacitor means making it flat. Let's look at the circuit operation of the switching type. In the switching type, the AC input voltage is directly rectified by the bridge diodes to create a pulsating current. This pulse is converted to high voltage DC by a smoothing capacitor. This high DC voltage is transmitted to the secondary side by stepping down the high voltage square wave on the primary side of the switching transformer by turning the switching elements on and off. After the square wave transmitted to the secondary side of the switching transformer is rectified by a diode, smoothed by a capacitor, it outputs the final DC voltage. The feedback and control circuit at the bottom is configured to ensure that the final output voltage is always a constant voltage. When the output voltage is low, the switching pulse width is widened. And conversely, when the output voltage is high, the switching pulse width is narrowed to ensure that the final output voltage is always constant. This type of switching pulse is called PWM, or pulse width modulation. And the frequency of the switching element uses a high frequency band of 100 kHz or more. The reason is that by using a high frequency band, the transformer can be made smaller and lighter. A power circuit that rectifies and smooths AC input, uses a switching transformer, and performs high-speed switching to obtain a final DC output is called a switching mode power supply. or SMPS for short. Compared to the transformer type, the switching type has a complex circuit configuration due to the switching elements and control circuit. But it has a great advantage in terms of miniaturization and weight reduction because it can be handled with a small transformer through high-speed switching control. Now, let's take a look at the actual SMPS circuit and its configuration and operation flow. This circuit is an AC-DC circuit based on onsemi's SMPS IC, NCP1200, and outputs 6.5 volts and 600 milliamperes of direct current for a free voltage AC input of 90 to 260 volts. A bridge diode for rectifying the AC input, smoothing capacitor for converting high voltage pulses to DC current, and a switching transformer to reduce the primary square wave and transmit it to the secondary side. Switching device for high-speed switching of high voltage DC. A diode and a smoothing capacitor to convert the square wave of the secondary side of the switching transformer into DC. A photocoupler, which is a feedback element to keep the output voltage constant. And it consists of a control IC for driving the switching device based on the feedback value. The AC processing area on the left side of the switching transformer is called the primary side, and the DC processing area on the right side is called the secondary side. The reason for this separation is to electrically separate the secondary side, which can be touched by actual human hands, from the primary side, and as this is a safety-related part, it must be designed with this type of insulation structure. The photocoupler used for feedback is also due to the insulation between the primary side and the secondary side. Let's look at the advantages and disadvantages of each type of AC-DC converter. The efficiency of the transformer type is low at less than 50% due to the loss of the transformer itself, while the efficiency of the switching type is high at over 70%. The noise of the transformer type is small because it simply steps down the 50 or 60 Hz alternating current and smooths it, while the noise of the switching type is large because it switches at a high frequency of 100 kHz or more. Free volt means whether or not it can always produce a constant DC output regardless of the AC input voltage. The transformer type cannot have free volt because the turns ratio of the transformer for stepping down is constant, while the switching type has a structure that controls the pulse width by feedback and control circuits, so free volt is possible. The size and complexity of the circuit are simple for the transformer type and somewhat complex for the switching type. In other words, the transformer type is large and heavy in terms of appearance, and its size is determined by the power. On the other hand, the switching type is small and light because it uses a small switching transformer. In the past, the transformer type was mostly used, but these days, due to various advantages such as energy efficiency, lightness, and free volts, almost all of them use the switching type, i.e. SMPS.